Okay, so today our group will present about application of logic in real life. So what is mathematical logic? Mathematical logic is a branch of mathematics that explores the application of formal logic to mathematics. It provides a framework for representing mathematical reasoning and proof in systematic and rigorous manner. Mathematical logic involves the study of formal systems, symbols, and the rule of inference to understand the nature of mathematical reasoning and the functions of mathematics itself. So when we use mathematical logic, these two are examples on where we use that. For first, in computer science and programming, mathematical logic forms the foundation of computer science, particularly in the design and analysis of algorithms, programming language, and software development. Boolean logic is extensively used in creating logical condition and decision making process in the code. For artificial intelligence, which is AI, mathematical logic is crucial for representing knowledge, making decisions, and solving problems. Logical reasoning is used to model intelligence behavior, plan strategies, and automate decision-making process.
For application of logic in real life, we have two different concepts, which is logical connectives and truth table. What is logical connective? Logical connective is a simple statement that will consist only a statement in which it has one subject and one predicate. It is also known as primary statement. A few primary statements can be combined to form a compound statement. The truth value of a compound statement is completely determined by the truth value of its primary statement. The primary statements are combined using connectives, which is logical operators to form a compound statement. So based on the table, we have five different logical connectives components. For the first logical connective is we have conjunction. So we use it for AND statement. For second logical connective, we have disjunction, and we use it for OR statement. For the third logical connective is negation. We use it for NOT statement. For the fourth logical connective, we have conditional or implication. We use it for if then statement. For the fifth logical connective is biconditional. We use it for if and only if statement.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adam Darwish bin Zulkili, and I will explain what is truth table. A truth table is a mathematical table used in logic which sets out the truth values of the logical expression on their functional arguments. A truth table can be used to show whether a proposition is true for all legitimate input value, logically equivalent, or logically implies. The truth table has one column for each proposition, all or input variable, and one final column that shows all of the possible results of the logical operation of the input variable. Each of the proposition will have two true value, which is true f or 1 or false f or 0. So this is the example of truth table. In this table, we have two input, which is P and Q. In the first column, P, the true value for this is true, true, false, false. And the next column, Q, the true value for this is true, false, true, false. Next column, negation. This column negates the statement of P, which is we negate the true value from P, such as, for example, from true become false, from false become true. So in this column, the true value is false, false, true, true. Fourth column, conjunction. So P and Q. If P is true, then Q is true, then P and Q is true. Otherwise, P and Q is false. So when the two input P and Q is true, it will return true. Otherwise, if one of them is false, it will return false. So for this column, the truth value is true, false, false, false. So for the fifth column, this junction P or Q. So for this, if P is true or Q is true, or both P and Q are true, then P or Q is true. Otherwise, otherwise P or Q is false. So, for example, if P is true, then Q is false, it will still return true. But if both of them is false, then it will return false. So for the true value of this column is true, 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 false. And for the sixth column, conditional, P implies Q. If P is true, then Q is false, then P implies Q is false. Otherwise, P implies Q is true. So, for example, when P is true and Q is false, it will return false. But when P is false, then Q is true, it will return true. And if P and Q is the same true value, it will return true. So for this column, the true value is true, false, true, true. Next column, biconditional. P, P biconditional Q. If P and Q give the same true value, then P biconditional Q is true. Otherwise, P biconditional Q is false. For example, when P is true and Q is false, it will return false. But when two of them um, are the same, true, true, it will return true, or false, false, it will also return true. And for this column, the truth values is true, false, false, true. This is our group case study. Below is logic circuit to control air cooling system. The input is AB and the output is fan, air conditioner, and window. So if the input is 00, the coolness is off and it will return output which is close fan, close air conditioner, and close the window. Next, if the input is 01, the coolness is fresh air and it will return output open fan, open window, and close air conditioner. Next, 1, if the input is 10, the coolness is cool and it will return the output which is open air conditioner and close fan, close the window. Next, if the input is 11, the coolness is cooler and it will return open fan, open air conditioner, and closed window. Okay, assume that 1 is open or true and 0 is closed or false. If this is the variable, if A, B, both of them is false, so fan, air conditioner, and window will become false. If the input A is false, the input B is true, fan will become true, air conditioner will become false, and window will become true. If A is true, B is false, fan will become false, air conditioner will become true, and window will become false. Next, if the true value of A is true, if the true value for both of them is true, the fan is true, air conditioner is true, but window will become false. So this is our first question. Not A and B or A and B. Logically, equivalence with f. We know that f is stand for fan, and we got the true value of it from the case study that I explained just now. So for f, the true table, the true value for this is true, false, true, false. This table have two input, which is A and B. For first column A, the true value is true, true, false, false. And for next column B, the true value is true, false, true, false. Third column, negation of A, negation not A. We negate the true value from A, so it will become false, false, true, true. Next column, fourth column, not A and B. Conjunction. We will take the true value from column not A and also B. So conjunction, it will return the true value false, false, true, false. Fifth column A and B, we take the true value from A and B. Conjunction, also it will return true, false, false, false. Sixth column, not A and B or A and B. We take the true value from the fifth column and also from the fourth column. We disjunction it. So it will become true, false, true, false. As you can see, the true value of not A and B or A and B is the same as the true value of column F. So it is logically equivalent because the all of the true value are the same. So for conclusion, we assume that not A and B or A and B is column 6 and F is column 7. Conclusion: since the true value at column 6 and 7 is equal, therefore not A and B or A and B and F is logically equivalent.
So this is the answer for question B, which is not A and B logically equivalent with W. So this is way to solve that. For A, the true value is false, false, true, true. For B, for true, false, true. Not A, true, true, false, false. Not A and B, false, true, false, false. For W, false, true, false, false. So the conclusion, since the true value at column 4, which is not A and B, and column 5, which is W, is equal, therefore not A and B is logically equivalent with W.
For question C, A and not B or A and B is equivalence to C. For first column we have A, the truth table is true, true, false, false. For the second column we have B, which is true, false, true, false. For the third column we have not B equals to false, true, false, true. For the fourth column we have A and not B, which is false, true, false, false. For the fifth column we have A and B. The truth table is true, false, false, false. For the sixth column we have A and not B or A and B. For the truth table we have true, true and false, false. For the seventh column we have C. For your information, we got C from case study is we get the input from A and B. So if A true and B is true, the C also true. If A is true and B is false, the C will be true. So for if A is false and B is true, the C is false. So if A is false and B is false, so C is false. So for the conclusion here is since the truth value at column 6 and 7 is equal, therefore A and not B or A and B is equivalent to C. For conclusion, using mathematical logic in our daily life help us make better decisions and solve problems more efficiently. Whether it's personal choices, education, or work, logical thinking enhances our ability to analyze situations, foresee outcomes, and devise effective strategies. It is like having a reliable guide for making sound choices, fostering clarity in communication, and contributing to a more organized and thoughtful approach to life's challenges. So, Embracing logical reasoning isn't just a theoretical concept, it's a practical tool that can positively impact our personal growth, professional success, and relationship.